Hello students, let us continue our discussion on expected value and probability standard deviation. We talked about the definition of the expected value and the definition of the variance and standard deviation. They are just computational formulas. And then we went through some elementary example. Now, what if we have the mass function? And what if we have the cumulative distribution function? If you have a mass function, can we calculate the probability, if you have a probability mass function, can we calculate the expected value and the probability standard deviation? We're going to do that. And then later, when we have cumulative distribution function, CDF, then how can you find out the expected value and the standard deviation? This one's easier, so let's do it first. So what's the definition of the expected value? Here we go. All we have to do is multiply the outcome times probability, outcome times probability, outcome times probability, and add them all up. So we have outcome here times the probability, payoff times the probability, and so on and so forth. So multiply horizontal, 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 and adding them all up. By the way, if you have horizontal table for a probability mass function, then the multiplication should be vertical. Here I'm using vertical table because we used horizontal table before. Excuse me, I'm talking about this. Where's an example of PMF? Okay, in this case we have horizontal table. All the x values and the probabilities are there horizontally, but the horizontal table does not take up too much space. But then again, if you have really a lot of possibilities, then you're going to run out of space very soon. And vertical table, even if you have 20 possible slots here, you can still handle it. But then again, you don't have 20 slots. You have only what? 1, 2, 3, 4 slots. Not a difficult computation. Anyway, too much digression. Let's begin. First, some color coding, just to help us out. And then multiply, 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 multiply. And there you go. That's the expected value. And once we have the expected value, we calculate each payoff minus the expected value so that we get the deviation, and make sure you square it. If you don't square, then you get pluses and minuses canceling each other out. Always you get 0. So square it to make it positive and weigh it appropriately with the probability. The more likely, the more important. The less likely, close to 0, not as important. So just use that computational formula here and do your computation, take the square root, and then that is the probability standard deviation. Without the square root, this computation, this part is the variance. Okay, that was easy. If you have a probability mass function, that's easy. Now what if you have CDF? In that case, it's not that easy because if you go over to all these definitions, we need probability masses. We need these PIs. So from CDF, you have to find out the PMF first, and then you can apply all kind of things. Basically, this is what you have to do. Let's see. At 0.25, we have a separation. At 0.5, we have a separation. And 1.25, we have a separation. And then at 2.0, we have a separation. By the way, I'm using the same example as before so that nobody gets confused. So if you're a little bit unsure about this conversion, you can always scroll up and go to the previous example because I didn't change anything here. So from here, you can get the probability mass function. So the x value is going to be 0.25, 0.5, 1.25, 2.0, or, and finally, otherwise. Okay. Almost there. Okay, all right. These are the possible values. And then the probability. Okay, what do we have here? From 0 to 1/3, we took that jump. So subtracting, we get the probability mass of 1/3. Next, from 1/3 to 1/2, we did this accumulation. So going backward, we have to subtract, and that is 1/6. And now from 1/2 to 3/4, and calculating this, what do you get? 1/4? And then from 3/4 to 1, by subtracting, what do you get? We get 1/4. And that's brown. And then otherwise, of course, the probability is always 0. Make sure all these probabilities add up to 1. Otherwise, something's wrong. So what did you get? We got the mass function. So it's not too difficult to find out the expected value now. All you have to do is multiply the payoff times the probability, payoff times the probability, payoff times the probability, all those multiplication, and then add them all up. And 1.25 is the payoff times 1/4 is the probability, and finally 2.00, 1/4 is the probability. Let's see, this is blue, and that's red, and that's green, and brown. Let's see, what do you have? Oh, this is what I'm getting. 0.97 something. Oops. Okay, that's better. Okay, there goes my expected value computation. Does it make sense? From CDF directly, you can't do it. So you have to get PMF first. And then from PMF, you can put everything into this expected value formula, and then you can calculate. It's easy. Multiply, 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 and adding them all up. Now, how about the standard deviation? Well, let's calculate the variance first. Oh, what was I thinking? I should have just copied and pasted this thing. And then let's do variance. And then everything's approximation, so let's just change it there. And let this one minus this number. Minus that, minus that. Am I missing something? Oh yes, I am missing something important. I just did a deviation. I did deviation squared times the probability. Deviation squared. Deviation squared. I need squared. And let's calculate this entire thing. 0.49 something. I guess that's a variation. All right. And thus the probability standard deviation, which is square root of the variance, which is approximately the square root of this, what's this? Let's run the calculation. 0.703 something. Okay. There you go. So expected value, not too bad. Just multiply, 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 and then add them all up. And the variance. Similar to expected value computation, we have the order weighing by all the probabilities here, but each time you're multiplying the deviation squared. Deviation squared, deviation squared, and so on. And once you get the variance, don't forget to take the square root. Okay, all right. So much for the computation. Oh, by the way, let me make just a little bit of comment here. Just a little bit of comment. Before making this recording, I did some computation myself, and then I made this computation mistake. You see, I have to check my notebook is correct, and even though I check and recheck, I still find some mistakes, and then I have to correct it on spot, but I do my effort anyway. And then the mistake I'm talking about was this. I somehow calculated times 4 instead of the probability of 1/4 here, and then got something ridiculous. 8.479 something. How do I know this is ridiculous as an expected value? Well, the smallest possible x value is 0.25, the largest possible is 2.0, and there's something in between. So the expected value must be somewhere in between. This is the smallest possible, that's the largest possible. The expected value must be somewhere in between the two. But I got something bigger than the maximum. That's impossible. That's not right. Of course, I immediately saw it and then checked through my computation. I missed dividing by 4. Instead, I multiplied by 4. So I went back and then calculation. Okay, all right. This makes sense. And that's how I found my mistake and corrected. Let's recap this. If you make mistake, and if you get some numbers, you have to have a certain sense. Does it make sense or not? And if you ended up with some subtle mistake and get something like this, it's nearly impossible to correct. This kind of mistake, I usually don't take off any point, just full credit. Wrong answer, but full credit, because it's just computation mistake. Now this kind of answer, this is going to be deduction because this does not make any sense, and my expectation is you have some certain sense so that, hey, this doesn't make any sense because it's bigger than the maximum. For example, if you do a standard deviation computation, get some negative value, that can't be right. We are adding up all those positives. And those kind of sense I do require.